Welcome back, student. Now today we'll start a new chapter that is basically psychometry, and which is basically important in your RSC subject. And when you actually discuss the air conditioning part, the psychometry will be an important role in that concerned. So psychometric, okay. Now and in this chapter we can able to learn actually there are some psychometric terms like dry air, moisture air, saturated air, degree of saturation. So these are the dry bulb temperature, wet bulb temperature, relative humidity, absolute humidity, and lots of other terms which are related with psychometric. And there are some psychometric processes like cooling humidification and cooling dehumidification, bypass factor. So all these things will be included in this chapter, which you are able to learn after this chapter, okay. And which is very much important for your concern your air conditioning. Now psychometric, discuss about the psychometric. Now what is psychometry? First the question will be asked in your mind that what is psychometry. Now psychometric is that branch of engineering which deals actually the study of moisture air. Now the question will be your mind that might become your mind that actually air is not totally dry in condition in our atmosphere. So air is basically it is dry air as well as moisture air. Now we are only concentrate, or actually we are only interested to study or to deal the study of moisture air, okay. Because in normal air or in dry air actually there is no as such air which have no moisture in the have not present moisture actually in that particular air. So moisture would be present for a particular air, for air actually. So we are only able to learn which deals with the study of moisture air. So in psychometry is that type of branch of engineering science which deals with the study of moisture air. Also it can able to learn that the study of some behavior of dry air as well as some water vapor, okay, water vapor mixture which is under various set of conditions. Because air is sometimes is flow in different set of conditions. So it may be in cooling, it can be humidification, dehumidification conditions. So at that particular time, at that particular situation, what are the different types of behavior or what are the different types of properties that can change of a suitable for dry air and water vapor, what should be the change that we can observe by means of psychometric chart or psychometric processes. So we can able to learn from psychometric chapter all these things. Now so basically psychometric is particularly a branch of engineering science which deals with the study of moisture air. So this is the important, which basically deals with the study of moisture air, okay. And also it can also include the study of behavior of dry air and the water vapor mixture under various set of conditions, okay. Now there are some terms which is related with psychometric. First is dry air. As we know that air is basically, it may be dry air, it may be moisture air, as you know. But dry air basically mixture of number of gases such as nitrogen, which are basically present in our normal atmosphere. So basically like that nitrogen, oxygen, carbon dioxide, hydrogen, nitrogen, neon, argon, helium, so much gases are there. So basically this is called basically dry air. But in between all of these gases in our atmosphere, that maximum percentage of gases that present, that is basically nitrogen, then after all oxygen, okay. So dry air basically the mixture of number of gases. That dry air may be nitrogen, oxygen, carbon dioxide, like that. That is called dry air. Because dry air there is no as such moisture are present with that particular air, that's why it is called dry air, okay. Now moisture air. So obviously moisture air is basically mixture of dry air as well as water vapor. If any in vapor the air is present in dry air conditions as well as there are some also present in water vapor, then it is called moisture air or moist air, okay. Now saturated air. Saturated air, it's basically mixture of, as we know that air basically normally mixture of dry air as well as water vapor. Now it's a basically mixture of saturated air. If you define the saturated air, it can be defined as that it's a mixture of dry air as well as and water vapor. Basically, when the when we call the air as a saturation or saturated, when the answer will be that when the air has diffused the maximum amount of water vapor into it, because of air has some capability to absorb water vapor into it. Okay, water vapor into air. So air has some capability. So when the air has some capabilities to do that, so when you do that, the maximum amount of water vapor absorbed or maximum amount of which are actually diffused maximum amount of water vapor into it, then water vapor actually occurs in the form of, then it is called, you can say that is a saturated air. Okay, so because air has some capability to absorb the water vapor. Now at these conditions, at which conditions the water vapor that absorbed by air, that particular time air to be called as a saturated air. Okay, now as we know that basically water vapor as basically occurs in the form of superheated steam. Actually we know that this is basically invisible gas, and when the saturated air is cooled, so when the saturated water is cooled means that in air the maximum amount of water vapor already present within particular air, so that's why the air is called saturated air. Now the saturated air is cooled. Now when it is cooled, the water vapor actually start condensing, and the same may be visible, and after all that the things what happens that the same may be visible in the form of fog, which are basically seen normally in our atmosphere. So that is basically due to these happenings. Okay, that's why it is called saturated air. So saturated air is defined when the air is diffused the maximum amount of water vapor into it, then the air is said to be called as a saturated air. Okay, because of air has a capability to absorb the moisture, air or water vapor. So that's why it is called saturated air. At which condition, that's why it is called saturated air. Now, degree of saturation. Degree of saturation is also important. Degree of saturation, actually the name suggests degree of saturation. So obviously the name suggests there are some related with saturation or saturated. Okay, so what amount of saturation takes place, so that's why that indicates the degree of saturation. Now the definition says that it can be defined as the ratio of actual mass of water vapor in a unit mass of dry air. So basically to the mass of water vapor in the same mass of dry air when it is saturated at the same temperature. So basically in a dry air, in a unit mass of dry air, what amount of actual mass of water vapor present to the water vapor present in the same mass of dry air when the dry air is reached to the saturated state, then at the same temperature, then it is called degree of saturation. That indicates the degree of saturations. Can you understand? Okay. Degree of saturation basically defined that what amount of, because as you know that in any air, actually in dry air also, there are some water vapor also present. Some water vapor are present. It may be 1%, 2%, 3%, or maybe 10, 20, 25 like that. But there are some water vapor are present in a unit mass of dry air, right? Now that is basically ratio or actual mass of water vapor in a unit mass of dry air to the, at a particular time, at a particular pressure temperature combination, maximum water vapor, maximum amount of water vapor that can be possible. It can be possible that maximum amount of water vapor it absorbed by the air. So that can be possible at a particular pressure temperature combination. Now if it is possible, then at that particular time, what amount of mass of water vapor present of dry air when it reached to the saturation state or saturated at the same temperature, that ratio is defined actually degree of saturations. Okay. Now if we go further, the next thing is that humidity. All you learn actually all you have some knowledge humidity. What is humidity? Now humidity is basically defined that what amount of mass of water vapor present in 1 kg of dry air, that indicates humidity. So basically it is defined, suppose in 1 kg of dry air, what amount of mass of water vapor are present, that indicates humidity. And it's basically defined with gram per kg of dry air. Gram per kg of dry air. So gram per kg of dry air means, per kg of dry air means in 1 kg of dry air, what amount of water vapor present? It may be 20, it may be 30 gram, it may be 50 gram, it may be 60 gram. So that amount, that ratio indicates the humidity. So basically the amount of water vapor present in 1 kg of dry air, that is basically humidity. Okay, and it is also sometimes also called specific humidity or humidity ratio. Okay, it's very important. We can discuss later in the lecture video what is the relations between humidity or absolute humidity ratio with dry bulb temperature, dew bulb temperature, what is relative humidity, and what is the relations between relative humidity with dry bulb temperature. We can discuss on the later in the next lecture video. Now, so this is the introduction part of psychrometric chapter. So that's why first we have learned that some definition or some terms which are related with psychrometric process. Now, absolute humidity. Now, absolute humidity is defined, same things, humidity concept is like that. In 1 kg of dry air, what amount of mass of water vapor are present, that indicate humidity, right? That is basically humidity. Now, the difference is that with humidity to absolute humidity, right? So this humidity and this absolute humidity, the difference is that we are considering 1 kg of dry air. Now it is basically in 1 meter cube of dry air. So that is the difference. Other than all the things are same. Like it is the mass of water vapor present in 1 meter cube dry air, that is called absolute humidity, which is basically defined with, which is basically designated with gram per meter cube of dry air, and in case of humidity, gram per kg of dry air. Gram per kg of dry air means what amount of mass of water vapor present, that is basically here in case of humidity, that is gram, and in 1 kg of dry air, in case of absolute humidity, in 1 meter cube of dry air. That's why it's called absolute humidity. Okay. Now it's relative humidity. Okay, relative humidity, which is also written as capital R, capital H. Now relative humidity, as the name suggests, so that will be the ratio. That will be the ratio of to humidity. That is basically in case of actual mass of water vapor in a given volume of moisture air to the mass of water vapor in the same volume of saturated air at the same pressure and same temperature. Okay. So relative humidity means actual mass of water vapor in a given volume of moisture air. Actual mass of water vapor in a given volume of moisture air. So and as you know that in a moisture air, there are some air are present as a dry in condition, and some part of air is basically in water vapor in condition. So what amount of suppose moisture air is, suppose total moisture air is suppose mkg, within mkg, if the actual mass of water vapor present is, that is mv. Okay, now to the mass of water vapor in the same volume, but condition is that volume is same, but the condition is that now the moisture air is reached in saturated air. So in a saturated air, what amount of water vapor are present in the same volume at the same pressure and temperature, that defines the relative humidity. So humidity is the amount of water vapor present in a dry air, that is defined humidity. Absolute humidity is amount of mass of water vapor present in 1 meter cube of dry air, that is absolute humidity. Now relative humidity is actual mass of water vapor in a given volume of moisture air to the mass of water vapor in the same volume of saturated air at the same pressure and temperature. Okay. Now next important thing is that dry bulb temperature and wet bulb temperature. Now, what is dry bulb temperature? Dry bulb temperature is basically ambient temperature, is normally atmospheric temperature, as you can say that. Dry bulb temperature, it can be defined as that temperature of air which is recorded in thermometer. So the temperature of air which is recorded in the thermometer when it is not affected by the moisture present in the air. So that is called dry bulb temperature. Now dry bulb temperature is basically temperature of air recorded in the thermometer when it is not affected by the moisture present in the air. So as you know, suppose this is your thermometer. Suppose this is your thermometer, right? And this is your mercury level. Okay. So this is your reading and this is your mercury level. Now, so this is your bulb in your thermometer, which indicate the temperature of your air. Now, when the air passes through this, when the air is flow through this or passes through the thermometer, the bulb of the thermometer is indicate the temperature of air like 30 degrees centigrade. Now, at that particular condition, that it is not affected by the moisture. Okay, if the moisture is not affected in the air, then the temperature is called dry bulb temperature. So the bulb indicates the temperature when the air is in dry conditions. That means the moisture is not affected. Okay, which is when it is not affected, that moisture is not present in the air. At that particular time, the thermometer of the bulb of the thermometer which indicates the temperature, that temperature is called dry bulb temperature and generally denoted by TD or TDB. That's why it's called dry bulb temperature. And the second thing is that wet bulb temperature. As the name suggests, that wet bulb temperature. So basically temperature of air basically indicate your thermometer. Now suppose if you want to measure the temperature of the air which is basically in wet condition, then the recorded temperature is to be called as wet bulb temperature. Now what is the process? Now temperature, because wet bulb temperature is defined, first wet bulb temperature is defined, the temperature of air recorded by a thermometer when its bulb is surrounded by a wet cloth exposed to the air, then it is called wet bulb temperature. So that means, so suppose this is your thermometer and this is your reading of the thermometer which indicates the temperature of the air. That air may be dry in condition, that air may be wet in condition. But when you discuss wet bulb temperatures, suppose this is your thermometer, this is the bulb which indicates the temperature of the air, that may be wet. Now, so this is the mercury level. That mercury level indicates the temperature of the reading. Now, suppose this thermometers is wrapped with some wet cloth which is exposed to the normal atmosphere. Now, air is passes through this wet cloth which is surrounded by the thermometer. When it happens so that air has, as you know, that air has some capability to absorb some moisture because air has some higher temperature that moisture, wet cloth temperature is low. Now air want to be absorb some moisture from wet cloth. When the moisture is absorbed by the air, the temperature will fall down or decrease. At that particular time, which temperature is recorded in the thermometer, that temperature is basically called wet bulb temperature, or shortly it is called WBT, and it's generally denoted by TW or TWB. Okay, so that is called wet bulb temperature. Now one interesting point is that, suppose, as you know that relative humidity, suppose relative humidity is 100%, right? Suppose relative humidity is 100%. That means in a air, maximum amount of water vapor already present, right? Relative humidity 100% means what? Means maximum amount of water vapor are present already within that air or moisture air. In that particular conditions, dBT temperature is equal to WBT, or dBT less than WBT, or dBT greater than WBT. Which one is right? Can you tell me? So think yourself. So try yourself that what will be the right answer. If relative humidity is 100%, then which option is right? dBT is equal to WBT, dBT less than WBT, dBT greater than WBT. Which one is right? Now we can discuss later in the next lecture video on this topic or on these questions. You can try yourself in your homework. So okay, thank you very much for listening and watching me. And in the next lecture video, we'll discuss on the different relationship of different, like with dry bulb temperature to wet bulb temperature, and the relationship between specific humidity or with absolute humidity to relative humidity. Okay, so all these things will be discussed on the next lecture video. So thank you very much for listening and watching me, and goodbye.